Welcome students. In this video, let us look at what even and odd functions are. A function f of x is called an even function if f of minus x is equal to f of x for all x belonging to the domain of the function. So f of minus x is equal to f of x for all x belonging to the domain, then f of x is called an even function. And f of x is called an odd function if f of minus x is equal to minus of f of x for all x belongs to the domain of the function. For example, so if you have f of x is equal to sin x. So if you are asked to check whether this function is an even function or an odd function, you just need to find f of minus x. So f of minus x is equal to sine of minus x. And you know what sine of minus x is? Sine of minus x is minus of sin x from trigonometry. That is nothing but minus of sin x is nothing but f of x. So f of minus x has turned out to be minus f of x. Hence, sin x is an odd function. F of x is equal to x square. Let us take this function. F of minus x is equal to minus x whole square. And minus x whole square is nothing but x square. It is again equal to f of x. So f of minus x is equal to f of x. Hence, x square is an even function. So if you have any function, put minus x in the place of x. If you are getting exactly the same function, it is an even function. If you are getting a minus extra, it is called an odd function. So if you take f of x is equal to x square plus x. F of minus x is equal to minus x whole square plus minus x. That is equal to minus x whole square is x square. Plus of minus x is minus x. So f of x is x square plus x. F of minus x is x square minus x. This is not equal to f of x. It is neither equal to minus of f of x. F of minus x is neither equal to f of x nor equal to minus f of x. That means this function is neither even nor odd. That means even function and odd function are not complementary to each other. That is, if a function is not even, there is no necessity that a function is an odd function. And if the function is not an odd function, there is no necessity that the function should be an even function. So how do you check whether a function is even or odd? Just put minus x in the place of x. Just look at how the function gets simplified. If you get exactly the same function, then it is an even function. If you get a minus extra, then it's called an odd function. If none of these happen, it is neither even nor odd. If you look in terms of graphs of even functions and odd functions, the statements are the graphs of even functions are symmetric about y-axis. So if the graph of a function is symmetric about y-axis, it is an even function. And the graphs of odd functions are symmetric about origin. So let us see what these statements mean. So if you take a function y is equal to f of x. So let us say that f of x is an even function. Now let us say that the domain of this function is all real numbers, and let us assume that we know the graph of this function on the positive side of x-axis. Assume that the graph of this function looks something like this. This is the graph of this function. So this is 0, 1, 2, 3, 4, 5, 6, so on. Now, can you predict the graph on the left side, given that this function is an even function? The answer is yes. So how do we predict the graph on left side? So the property is f of minus x is equal to f of x. So if you put x is equal to 1, so f of minus 1 should be exactly same as f of 1. F of minus 2 has to be exactly same as f of 2. These are sample points. This has to be valid for every value of x. So let us take some sample points. F of minus 3 has to be exactly equal to f of 3, so on. So if you see f of 1, so if you draw f of 1 is somewhere here. So f of minus 1 has to be also the same value. F of minus 1 also has the same value. Similarly, f of 2 is has this magnitude. So f of minus 2 should also have the exact same value. Similarly, f of 3 and f of minus 3, f of 4 and f of minus 4, and it has to go on. And this has to be valid for every number in between 0, 1, 2, 3 for all real numbers. So as you draw the graph, you can see that the graph follows exactly the same path as the path on the right side. So do you see that you get the exact same graph? Whatever you got on the positive side of x-axis, you just get the mirror image of this graph about y-axis. So this is how the graph of even function looks like. The graph is symmetric about y-axis. Okay, that means you can fold the graph about y-axis. Next, if you have a graph of f of x, if you have the graph of an odd function, let us say that y is equal to f of x is an odd function this time. So how does the graph of this look like? So assume that this is the graph of the function on the right side of the y-axis. So how does the graph look on the left side? So this time the condition is f of minus x is equal to minus of f of x. So if you put x is equal to 1, f of minus 1 is minus f of 1, f of minus 2 is minus f of 2, f of minus 3 is minus f of 3, so on. So f of 1, 0, 1, 2, 3, 4, so on. So f of 1 has this magnitude. So f of minus 1 also has the same magnitude but opposite sign, because f of minus 1 is minus of f of 1. So it has the same magnitude but on the negative side. Similarly, f of 2 has this value. F of minus 2 will have the same magnitude but in the opposite direction. Similarly, f of 3 is this much. F of minus 3 is this much. So if you draw the graph of this, so you get a graph which looks like this. So this graph is symmetric about origin. That means if you have any point, if you join the origin with it, if you extend this line, it meets the curve at the next point. So the midpoint of these 2 points will always be the origin. So wherever you take the point, join this. So the midpoint will always be the origin. Means the origin bisects every chord, bisects the the origin bisects every chord passing through origin. So this is called symmetry about origin. And you have a slight problem here. So all is good till now, but you have a slight problem at 0. So let us assume that f of x is an odd function. So f of minus x has to be equal to minus f of x. Let us apply this condition at origin, that is x is equal to 0. So f of minus 0 has to be equal to minus of f of 0. This implies minus 0 is also same as 0. F of 0 has to be equal to minus of f of 0. This implies 2 times f of 0 is equal to 0. This implies f of 0 has to be equal to 0. That means if an odd function is defined at x is equal to 0, it has to be equal to 0. It cannot be any non-zero value. That means if I take this graph, f of 0 cannot be this value. If f of 0 is defined, it has to be equal to 0. And if it is not defined, then it is okay. So I can have a hollow dot here. If I have a hollow dot, then this will be good. You have to have a hollow dot here. Means the function is not defined at x is equal to 0. Because if it is defined at x is equal to 0, it has to be equal to 0. This is a very important point for odd functions. If an odd function is defined at 0, the value has to be equal to 0. If the value is not equal to 0, it will not be defined at x is equal to 0. For example, if you have a function f of x is equal to 1 by x, f of minus x is equal to 1 by minus x, which is equal to minus 1 by x, which is equal to minus of f of x. So f of x is equal to 1 by x is an odd function. So how does the graph of this look like? The graph of this looks like this. We have a graph like this and a symmetric graph about origin on the negative side. Here, as you can see, f of 0 is again not defined. F of 0 is not defined. If it has to be defined, if it is defined, it has to be equal to 0. Otherwise, it is not defined.